All right, so today we're going to talk about the basics of chemistry, what chemistry is and what you need to know. So starting out, the most important thing to know is how to use a periodic table to get information. On the periodic table, you're going to see about 115 entries for different elements. Looks like this. Every entry on the periodic table represents a type of atom. Now an atom looks like this. This is a representation called a Bohr model. An atom is the smallest piece of matter that has its own unique identity and characteristics. And the type of atom is going to be known as an element, which you can see right here on this table. All of these are different individual elements. And when I say that it's unique, what I mean by that is that an atom of nitrogen is not like an atom of calcium. They're going to have different properties, different behaviors, different characteristics. When you look at the periodic table, within that entry, you're going to see three things that are very important. First, you're going to see the symbol. Then you're going to see a number that is called the atomic mass, and another number that's going to be called the atomic number. Atomic means pertaining to an atom. The location is important. Where something is on the periodic table is going to tell you some information about the atom and what it looks like and how it behaves. So again, looking up here, this is a very great example of a periodic table because it has different colors and there are certain characteristics that atoms that are within these colors share. For example, all the ones that are here in yellow are very good at conducting electricity. That's one thing to know. And we'll talk about that more often in the future. Looking at the periodic table, there are some important things to know about how the atoms are structured. Every atom that exists is made of three smaller particles called subatomic particles. Subatomic particles are below the size of an atom. And those three subatomic particles are protons, the ones here that are shown in red on this Bohr model, neutrons, the ones that are in yellow, and electrons. The protons and neutrons are located in the center, and they are collectively known as the nucleus of the atom. So all the mass of the atom is right here. Electrons are on the outside. They're much smaller, and they have almost no mass. So all of the mass in the atom is in the nucleus. And again, that nucleus contains the protons and neutrons. Electrons are on the outside. So here is an example of an entry. This is for beryllium. And what this shows us is four pieces of information that are very important. First of all, it's the elemental symbol. So this is Be. Always a capital letter is what it starts with. So Be is the symbol for beryllium. Here's the name. The smaller number up at top, this is the atomic number. And then there's a number down here below, and that's called the mass number. Now, the way this works and how you can use this information is when you see this 4, the atomic number is also going to tell you how many protons the atom will have when it's found in nature. Every atom that has 4 protons is beryllium. Also, when you look up here, this number is the size of the nucleus, is how many protons and neutrons there are together. Now you can see this is a very long decimal, and we'll talk about why that is in the future, but for right now, just know that the nucleus has 9 things in it, 9 total particles. Of that 9, 4 are protons. So if you want to find how many neutrons something has, just take this number and subtract the atomic number. So the atomic mass minus the atomic number is going to tell you how many neutrons are present. So here, beryllium has a 9 for its atomic mass, and you can see this long decimal right here, and again, we'll talk about why that is. But we have 9 total particles, and 4 of those are protons. That means that 5, 9 minus 4 is 5, 5 of these are neutrons. So looking up here, just to summarize all this information, the atomic number is the smaller number and the number of protons. The atomic mass is the mass of the particles, and again, that's going to be the protons plus the neutrons. To find the number of neutrons, simply subtract the higher number minus the smaller number, so the atomic mass minus the atomic number. And the last thing I want to say is that when we name this, we always say the name of the element and then the mass number. So this would be beryllium-9. We never say an atom of beryllium. We just simply say the name of the element, and then we say the number, that's the mass number, and this way we can communicate what the size of the nucleus is and how heavy it is in terms of mass. And the nucleus is all that matters. You get it? Matter, nucleus. It's a joke. I thought it was funny. All right, thank you for watching. You're the best.